Assalamualaikum warahmatullahi wabarakatuh. My name is Mohamad Amarudin. I'm from University of Brawijaya. I will review some journal. One is over-the-air LTE measurement in the reverberation chamber, modeling of the LTE radio interface for NRT traffic, design of session and error control signaling in 3GPP LTE system, the LTE radio interface, key characteristics and performance in small cell network, rethinking the radio interface beyond LTE advanced, delay aware resource allocation scheme for a cognitive LTE-based radio network, adaptive fair radio interface, scheduling for LTE network, the design of cloud-based 4G LTE for mobile augmented reality with smart mobile device, coordinate LTE uplink radio interface scheduling, and the last reward-based radio interface selection for hybrid 4G, UMTS, and LTE communication. Let's see. Over-the-air LTE measurements in the reverberation chamber. The third generation partnership project, or TGPP, has provided successful reports and specifications for long-term evolution for LTE. LTE system is called 4G system. The main difference between LTE and 3G predecessor is that the orthogonal frequency division multiplexing, or OFDM, and multiple input, multiple output, or MIMO techniques used in the LTE system. Thanks to the higher throughput can be achieved in the LTE system. To evaluate LTE when the end user experience over-the-air performance, testing of LTE device required. The next journal, modeling of the LTE radio interface for an LTE traffic. LTE network architecture has evolved from the previous generation architecture, the UMTS system. One of the most visible changes in the structure of the network is the transfer of radio protocol services. Customer mobility management and all the algorithms and functions are located in the UMTS radio network controller, or RNC, to the base station, which is called the Ethernet B, or ENB. The new architecture has been introduced to version released at LTE, also known as the Evolve Pack Core. Architecture LTE Evolve Pack Core is present in Figure 1. It's easy to see that the LTE access network architecture consists exclusively of base stations interconnected via the X2 interface and to the core network PS1 interface. The reason for the deployment of LTE network control between base stations is to speed up the connection setup and reduce the time required for submission. The second important parameter for the end customer more and more frequently demanding real-time based services, namely on online game or live streaming. The next is simplified architecture for LTE network. Design of session and error control signaling in 3GPP LTE system. 3GPP LTE system targeting optimal packet system that provides higher data rate and lower delay with better coverage and spectrum efficiency. LTE system require optimized signal and optimized radio transmission and radio access network. Key features of LTE system associated with the signal optimization has been proposed in 3GPP and this must be considered in designing LTE signaling protocol. KGBP LTE focus on new radio transmission technology while evolved UMTS, terrestrial radio access or AUTRA, and a new radio access network called AUTRAN. Along with LTE, KGBP has also been standard system architecture evolution, which includes the evolved packet core network over the AUTRAN. The LTE radio interface, key characteristic and performance. Free use of mobile broadband, demanding improved services and increased mobile network capacity. To meet this requirement, the GDPP has defined LTE GDPP long-term evolution. This journal presents some of the key characteristics of the LTE radio interface, include the function layer and physical management of radio resources, and evaluate their impact on system performance. Compare with the reference system with more basic characteristics, which are represented by the mobile WiMAX. The results show a combined gain in spectral efficiency of 63% on the downlink and uplink, 100% cell edge bitrate gain of about 100% in both downlink and uplink. Next, change small cell network, rethinking the radio interface beyond LTE advance. This journal provides an overview of a proposed cell radio interface for low latency network small cell solid. This journal discusses the physical parameterization layer and a new frame designed to support high energy and spectral efficiency in wireless small cell communication, and compare the main parameters with other physical layers designed for SG centimeter wave communication. The main emphasis in this design is to go beyond LTE advance to achieve the target design SG, while leaving room for further innovation. Index terms SG, rich network, energy efficiency, LTE advance, low latency, small cell network, and spectrum efficiency. The journal delay-aware resource allocation scheme for a cognitive LTE-based radio network. This journal explores the problem of resource allocation in the third-generation partnership project, LTE-based cognitive radio network. The network model consists of a number of service providers with distinct spectrum bands. These networks offer wireless service for two types of users, primary and secondary. The main users get priority access to license spectrum bands, and secondary users are presented in the best effort or non-priority. This paper considers the specific design features of LTE radio interface associated with uplink spectrum access, process scheduling, and limited control channel capacity of LTE system. Adaptive file radio interface scheduling for LTE networks. Radio resource management procedure developed in the 4G long-term evolution is to increase the spectral efficiency beyond that level ever achieved. Must be released by considering the optimal trade-off between system performance and fairness among users. This work also provides a sophisticated mechanism to estimate the congestion level of the radio interface. To help operation scheduling scheme adaptive pair. Proof of concept is provided with the help of simulation result in which the performance of the proposed scheme is evaluated at the level of permission-given radio interface. The design of cloud-based 4G for mobile augmented reality with smart mobile device. Service cloud-based 4G is one example of a telecommunication service with the combination of cloud-based deployment and increasing use of smart mobile device. There are a lot of interesting potential applications and services with real-time or interactive features can be made. Exploring the technology and mobile augmented reality application in a cloud-based BMS 4G and smart device environment. Applications are discussed in this journal include real-time accurate navigation, how to reach for indoor and outdoor, urban design collaborative, and multi-user interactive learning system in mobile environments motion. Coordinate LTE uplink radio interface scheduling. LTE radio interface promise much higher than the 3G access technology. Sometimes the bandwidth requirement of varying traffic LTE users can be met by existing transport network either because of the limited capacity or because of inaccuracies involved in the transport network bandwidth dimension. Next, now reward-based radio interface selection for hybrid 4G UMTS and LTE communication. 3GPP LTE set or specification of LTE advanced as a 4G system that works with existing UMTS system. To balance the load between the different communication interfaces in a hybrid cellular system is one of the most important issues that must be addressed in order to achieve an efficient allocation of radio resource. In the service packet together, the GPP UMTS adopts SFGDM interface for allocating orthogonal codes OVSF code free into dimension, deployment time and frequency domains. However, UMTS suffer high packet loss rate and high level was bandwidth. Yeah, it's time for my presentation. Thank you for watching. Wassalamualaikum warahmatullahi wabarakatuh.